way too close. Dang it. That was part of my intro. Let me get a little taller. Oh, man. Okay. I can't stand. Maybe I will. All right, here we go. This is the first time I've recorded in second period for like the whole semester. So I am recording. So if there's a lot of talking, your private conversations will be on video. All right, so let's look at this together. Just like in the warm-up, we're talking about similar triangles, right? Similar triangles, and in particular, angle-angle similarity. So if we have two triangles, just like in the warm-up, which I'll just point it over here. You know, in the warm-up, ooh, nice glare. We have two baseball fields, right? We figured out that they were similar because we had two angles in common. So that's kind of related to the lesson. What baseball field has a smaller field? Where do you see a smaller field? Softball, what else?
Little League.
Little League. Okay, so Little League, maybe their field is more like this, and their bases are closer together. So when we have this going on, say if I have between the two foul poles at the same angle, and do you think that it's easier or harder to get a foul ball in Little League? Is it easier?
No. Well,
they're little, so maybe they can't even hit it. Say they're pretty good. It's a Little League World Series.
it's like 16 feet to the first base.
Okay. Well, how about like what you said, the opening? Is it easier so that...
It's going to be the same, it's going to be closer base.
Good. So in Little League, from home plate, the angle is still opening the exact same. The same angle between, looking out between first and third. Same angle. Okay, so because we know that from home plate, it's the same angle as well. So even though this might be, instead of 90 feet, we might have 60 feet, right, between home and first. These two triangles are similar because angle and angle are in common. Angle and angle are in common. If we have two angles in common, that's all we need to know that they're similar. It doesn't mean they're the same. They're not exactly the same size, but just like with dilations, if it gets bigger or smaller in the same consistency, compression or stretching, then we know they're similar. Okay? That's really what we're jumping on into today. So just keep that idea in your head, and let's look back. All right. So just a quick thing, tick marks, like sides are congruent or the same. We have tick marks that are showing that they're the exact same measurement. Angles, also the tick marks show. So 2 and 2, those two angles match. So we're looking for congruent, which is just the same. Okay, it just means the same. We'll break it down further later this week. And then when we have these similar triangles, corresponding sides are proportional. So if your triangle stretches, right, the side over here stretches in the same K-factor as the side on the bottom. It stretches and gets bigger. So we can make those proportions between those sides. We can equate them. We'll do that as for the example over here. Let's see. This ratio between the sides, if they are similar, that's a similar symbol, then we know that the sides are going to have this same ratio between all of them. Orientation also matters. We have to be able to connect the sides that correspond to each other. So here are two triangles that are similar. Which one on this triangle corresponds to AB over here? Somebody tell me which one corresponds to AB over here, and tell me how you figured that out. What do you think? So look at that for a second. We're looking to see segment AB, what that corresponds to, what it is similar to in this triangle here. They don't have to be the same, but which one does it correspond to? How can you figure out? How did you figure out? DE is correct. How did you figure it out?
Well, A has the two angles, so I figured B has the same one, and then go up. Yeah.
Good. So you know that which side, here's the two tick marks for the angle, same down here. It's not going to be this side over here because that's between the two tick marks. I know it's a tick mark, and then this one's open apparently. Tick mark open. So yeah, DE. I want you to do the other two sides. Go ahead and just fill in those two blanks. Let's see. Carson, what's BC correspond to? FE. If someone else put EF, would they be wrong?
No, it's the same.
Same thing, right? EF or FE, it's a segment. Same endpoints on both sides, so whichever you say first doesn't matter. We can still figure out what it is. There's no, it's not ambiguous at all. Okay. Let's see, Justin, what corresponds to AC?
EF.
EF?
EF.
And DF. Good. DF. What was your logic for that? Okay, so you visually moved it around to figure it out. Okay, that's fine. That's good strategy. You might also flip it horizontally, or you can relate between the angle tick marks and figure it out from there. Okay. So this is just figuring out which sides correspond. If they correspond, then we can come and look at one way to get it similar. One way to prove that it's similar is if two angles are the same between two triangles, then the triangles are similar. So between these two, if these are similar, let's look and see. BAC and YXZ, those are the same. And ABC and XYZ are the same. Because we have two angles in common between the two, we know they're similar. So I could say right here, yeah, these are similar. Okay. That's all we had to prove. There's two problems in the beginning of this assignment coming up today that just asks you to verbalize your wording with that. Okay, that's all you have to do is verbalize it. All right, we're going to do this example together. So the way that I would have you set this up is write draw two new triangles, go and label it like this. This is going to be the way that we're going to approach these kind of problems. And I want you just to put in the information with me as we do. So we got our two triangles. I knew this was 25 feet. Okay, 25, 4, 16. You see, I'm just inputting it quickly, and we don't know that sound. So first off, I always draw the two triangles like this. In this example, we have this tree that's 25 feet tall. The shadow that it casts is 16 feet. This kid is 4 feet tall. The shadow that they cast is XZ, and we got to figure that out. We want to find XZ. How big is the shadow for the kid? Now, the way we're going to do this is, if I know that these two things are similar, then I'm going to create two ratios between the sides that correspond, and that's going to help me find it. So watch this. Which side, this is how I want you to do this problem. When you're approaching these, circle one of the sides, 25. First off, how many angles are in common between these two? How many angles do we have in common? Two. Because we know a right angle is the same in any triangle. It's 90 degrees. Remember, the box is right angle. It's not a box. Because these are right angles, we know that those are 90 degrees. We have this other angle in common. So because we have angle, we know that it's similar. Okay. So now we can relate the sides. What side corresponds to 25 feet over in this triangle? Name off the line segment that corresponds between AB. What's the line segment called?
XY.
XY. Right here, right? So watch, I circle these two, and I just connect them. That shows me that those two sides correspond, bless you, those correspond, and those are the ones we're going to use in our ratio. We'll have one ratio between those two sides, and next we'll have a ratio between 16, and what side does that correspond to? XZ, right? This is what I'm looking for, so I'm just going to call this, I'm just going to call it XZ, and those two correspond. You see how I just had to figure out and connect the ones that correspond? All right. So kind of hard to see at home. All I did was pick 25. I related it to 4 because they're similar triangles. Those correspond, and these correspond, just like so. Now watch what we're going to do. We're going to go ahead and make a ratio that has the same triangle on the top. So this is triangle 1. And then on the bottom, we're going to have the measurements for triangle 2. Just watch this. Just watch. Okay, let's relate triangle ABC and XYZ. 25 to 4. All I have to remember is whatever I put on top, on the other fraction I have to have the measurement from that same exact triangle. But here we're relating the two triangles, so 25 corresponds to what side? 4. Watch, 25 over 4. I've just created a ratio between two corresponding sides, and this ratio has to match the other ratio in order for it to have stretched or compressed the exact same amount. So 25 to 4, 25 to 4, and then 16 to XYZ. Which goes on top? 16, why? Same triangle, so 16 minus XZ. So just because that's a little bit harder to see, I'm going to write it again. So I just made the two ratios. I know they're equal. I know they're equal because the ratio corresponding sides, they're going to be the exact same if we have similar triangles. We already know they are. We already showed that they are angle-angle. So watch what I'm going to do. We're going to multiply 25 times XZ, 25 XZ. And that's going to be equal to 4 times 16, which is 64. This last bit is the last cross-multiplying aspect. But the main hardest part is setting up your ratios, which isn't so hard. Okay, we divide by 25 on both sides. XZ is equal to 4 divided by 25, 2.56. All right, then I want to go back and just, at the end, whenever you're doing these problems, go back and see if it makes sense. Just like, generally. 25 to 4, 16 to 2.56. Okay. So I look and I'm seeing 25 is bigger than 16, so this side is bigger. That makes sense that this is 4, this would be then 2.56. If you looked here and you said, oh, XZ is supposed to be 43 feet, right? That wouldn't make sense. I look here, if this was 43 feet, it would be like this, right? And I don't think that these two are similar, because now we've changed the angle. The angle isn't the same, and they have to be the same if they're the same, similar. Okay. All right, who needs to see another one like this? Want to see another? Does it make sense? Okay, setting up the ratio, just remember this is the key. And if you didn't, put a star to it. This has to be, let's see, the numerators from the same triangle, and the denominators from the same triangle. That's probably the biggest mistake that are made. Those two things switch around when people are in a rush. Don't be in a rush. All right, thumbs up, sideways, or down for this. I think when you get to, okay, good. When you get to working, you'll see how it all starts to make a little bit of sense. So, slide back in. All right, anybody have a shout out for people at home? Anybody want to say hi? No shout outs?
Shout out to Dwayne The Rock Johnson.
Oh, Dwayne The Rock, thank you for being there for Stanley. All right, so 123rd gets some Oreos. Sign up, sign your friends up, sign your animals up, whoever you want. Don't unsign up, please. Don't unsubscribe. All right, that's it.